So, how do you do the antiderivative of all those other derivatives that we studied the first half of the year? Do you know what I'm saying? We've learned a whole bunch of derivatives. That was a big part of chapter 3. There was the chain rule, there was the quotient rule, the product rule, and then other rules that were more of processes. Well, that's what we're going to now start to look at. To reverse the ideas from the first half of the year is a little bit more than when multiplying you're supposed to divide, or when sine now it's cosine. Those things are all true, but we have to start to get into how to reverse some of the processes. And this is fun. Okay, we're ready for like something new. You should feel like we've kind of been doing one-step problems pretty much for quite a bit of time. So you really don't need me to tell you that this function up here, 9 3x plus 5 squared, it's actually an integral. This integral is not one that you could have done on a quiz, not just because it's harder, but because you want to feel like that there is more than just one function. Yes, there is a power function here. Yes, you should see the square, but you should feel like there's more than just a square. When we say function in math, we mean like things that are being done to x, and so something else is being done to x. There's this inside piece as well as the outside piece. There is an inside function and an outside function. Now, just by the way, the number 9, as I've been trying to kind of warm you guys up, the number 9 is still just a coefficient. It just comes along for the ride. But the real deal is this green and blue part, the inside function and the outside function. Now, I'm saying that a couple times because I'm wondering if that's making you think about something that had an inside and an outside during the first half of the year. And of course, it should start with a C and rhyme with rain. It is chain rule. And what we're going to do is we're going to reverse the chain rule by basically trying to pull out the inside and be left with something simpler and doable. I know there's some text up here. You can read it, you can write it. Maybe you're just waiting to see what I'm going to do with it. I just want you to see these words because I'm going to use them. This idea of an inside, this idea of having something simpler. Okay, now this isn't like a magic show. I'm not like trying to make things appear and disappear before your eyes, but you're going to feel like maybe that I'm doing a little bit of that I'm changing things, but I'm changing things so that I can, as it says up here, I can pull out the inside. I can actually leave us with something simpler, and then we have to do a little thinking about even a derivative, you'll find out. Let's start with what you're going to grab onto is a pretty common strategy. That is to take the inside and literally let you, sometimes people kind of do this off to the side, not directly underneath, but wherever you decide to do it, you're going to let u equal 3x plus 5. Now, if you're already saying, what's u? Well, u is going to become a new variable that allows us to have a simpler integral. So we're just making a statement here that we're going to let u equal 3x plus 5. Now, this is going to be a little bit mathematical. It's actually just a derivative, but that means that the derivative of u, now make sure you're hearing me correctly because I did say the derivative of u That means I'm going to do the derivative of this like the first half of the year. Now, the derivative of 3x has always been 3. When you do the derivative of x, you're going to want to think of that as dx. And so we have ourselves doing a derivative where we think about splitting up the du and the dx. Okay, we actually called this, what did we call that? It just dropped my mind, but we're basically doing the derivative of both sides, so we have to have the du and the dx split up. Now, I get it if you're like, why are you doing all this? Just wait about one more step, and I think the why will become clear. But if this is true, which it is, then if I solve it for dx, if I basically get that 3 over to this side, then I'll be staring at something known as 1/3 du, and that will equal dx. So again, why did I do that? Well, you'll find out, but just notice I solved it for dx. Now I want you to go back up to this integral that arguably was complicated, and I want you to think about substituting some things that are equal. Substituting some things that are equal. First, what I circled is clearly going to be substituted to become the letter u. As you'll realize, that was the whole premise of this problem. I hope that you say, okay, that's true, Ms. Miller. I'm not sure why you're doing it, but it's true. I hope you also take this dx and feel like you want to substitute that. Oh, to be this solved little guy, to be 1/3 du. Now we're going to do one more simple step of algebra. That is 9 1/3. 9 1/3 can become the number 3. Make sure you don't miss what I did there. That was just a little algebra, but that allows us to have, ta-da, a simpler, doable integral. Now, you want to realize that you can do this integral. You say, what do you mean I can do this integral? That means you can find the antiderivative. I'm going to go back to the notation of capital F of x that you realize that I'm actually doing the antiderivative. So it looked like you did a really nice job on the quiz. Seriously, so make sure that you do the antiderivative here. That is that you add and divide. Okay, you change the exponent, so you get u to the 3rd power. Now that should feel a little bit kind of like a little bit wonky because I've got f of x and then I've got u. Well, there'll be a time where you skip this step and you'll say, yes, but u equals 3x plus 5. And so we actually substitute back and we say that u, which is equal to 3x plus 5, is to the 3rd power. And of course, don't forget your plus c. And that is your antiderivative. Good. I sometimes can't tell if we have a minute or if we just have 10 seconds. Take a look at this answer, and we'll do another problem, but just take a look at this answer. Do you believe it? Do you believe it? Do you believe if you do the derivative, that is, if you now go back, if you do the derivative of this, that you're going to get this? We can kind of do it mentally. 3 comes down. It becomes a new exponent of 2. And how are we going to end up getting 9 since 3 comes down? Do you see where we get the other 3? It's the derivative of the inside. So if you do the chain rule on this guy, you are going to go back to where we started. But if you start here, you're going to go back to this original equation. And it's using something called the substitution method. Okay, the substitution method. All right, that'll give you something to think about.